Hi guys, welcome to another episode of my YouTube lesson. In today's video, we are going to be looking at another question here that we can have in electrolysis. So we have a question here. The question goes like this: if the cost of electricity required to deposit 1 gram of aluminium is 4 naira, that is the cost that we are given. So how much will it cost to deposit 24 gram of copper? We are given the molar mass of copper to be 27 and the um, molar mass of aluminium to be 27 and the molar mass of copper to be 64. So if you see a kind of question like this, the formula to calculate the cost during any electrolysis question like this, any electrolysis that you are going to be given, so the cost will be equal to the cost that you are given upon the quantity of charge for the first element that you are the first element, the first cation that you are given, which is for the aluminium. I will represent it with the aluminium. So multiply by the second cation Q2, which is represented with C. So this is the formula that I'm going to use to calculate it. So having written that, let's write our given data out, what we are given in the question. The given data, our Q, let's write it like this: Q for the aluminium, the charge for the aluminium, the quantity of electricity rather, we are not given, so it's going to be unknown, which is Q. We don't have Q from the question. So the mass of aluminium, we have the mass of aluminium in the question, which is 1 gram. We have mass of aluminium to be 1 gram. And we also have the charge of aluminium, because aluminium is always written as this 3 plus, so it has positive 3 charge. It is 3, and the molar mass of aluminium, also given the molar mass of aluminium to be 27. So normally we also know 1 Faraday will be equal to 96,500 coulomb. So we are coming to that. So for the second quantity of electricity, which is for the copper, is also unknown. We are not given the mass of the copper. We are given, which is 24 gram. The charge of aluminium, then the charge of copper. Copper is C2 plus, so the charge is 2. We're going to copy the 2 down, followed by the molar mass. So the molar mass of copper, is going to be 64. Now, so after we have done that, so we now begin with our electrolysis formula, which is Q to be equal to MCF upon molar mass. Let's represent this Q now. Let's first do for the aluminium so that we can get the Q for the aluminium. So this is formula that you can use to calculate any equation under the electrolysis problem. This M represents mass, C represents charge. This charge that I have here, it represents charge. This F represents the Faraday constant, which is 6,500, then 6,500, and the M, this WM I put here is represent the molar mass. So I can write it like this: 1 multiplied by 3 multiplied by 96,500 upon 27. So this one will give me 10.722.2 quantity coulomb of electricity. And the second one, let's calculate for the Q for the copper. We are using the same formula, MCF upon molar mass. This one is for the copper. The copper we have 24 multiplied by 2 multiplied by 96,500, and the molar mass of copper we are given, which is from the question, which is 64. So we are going to have 24 multiplied by 2 multiplied by 96,500. This one will give us 72375 coulomb. Let me separate like this so that you're able to get it clearly. So having done all this, so our normal formula now I want to use to calculate the cost. Cost will be equal to cost given, the cost we are given upon quantity of electricity for the aluminium multiplied by the quantity of electricity for the copper. So the cost is from the question, the cost is 4 that we are given. So we are going to copy it there. We have 4, and upon for the aluminium is 10 points. 1072. It's no point. Don't be mistaken here. It's no point. Oh. So 10,0722.2 multiplied by 72375. So costs now. So we multiply everything. So we are going to have 4 divided by 10722.2 multiplied by 272375. So the cost is going to be 27.0 naira. 27.0 naira. So this is how you are going to be tackle this kind of question anytime you come across it under electrolysis. So come to the end of my today's class. Please, if you are new to my YouTube channel, please kindly help me to subscribe to it and press the notification button in order for you to know when I post another video like this. Thank you.